Lovely afternoon. That's enough of that. Good afternoon. Welcome back. So this afternoon I'm going to look at some Max for Live bits and bobs. And so to kind of, I suppose, try and round off some of the stuff we've been looking at in Max for Live. We've been doing a little bit of MIDI processing, or certainly did that before Christmas. And I've looked a little bit at processing audio. It'd be kind of interesting to look at making a synthesizer, or at least starting to build one. But the angle here is hey. The angle here is very much on adding to Max for Live's capabilities using external modules, but also making use of the fact that a lot of these Mutable Instruments hardware modules have been open sourced and turned into software, which we looked at this a little while ago now in VCV, and looked at the Audible Instruments ports of the Mutable Instruments modules. And there's a fella called Timo Rosendahl who's made complete Max for Live objects for Platts and another one. Probably should have checked exactly what it was, but there's two of them. Oh, these two, like Macro Oscillator and I think that's Clouds. But there's also this very talented programmers, this fella Volker Böhm, who has also added rings, braids, the reverb from Elements, the degrader thingy from Clouds, phase vocoder from Clouds, the resonator from Elements, and the 2-voice FM module from Elements. There's loads of stuff there, and if, like me, you're missing the modular and are tired of the world of VCV Rack, which is a little bit frustrating, particularly because it doesn't work as a plugin, I'm going to demonstrate some ways into that. So the first thing I'm going to do is make a new Max instrument. Let's just delete some of these unneeded tracks here. So we're going to make a new Max instrument, and then I'll really quickly run through how we might get a monophonic synthesizer up and running using some built-in objects, and then I'll show you how to add new objects to Max, and therefore Max for Live, for doing some other interesting stuff. So this is an instrument. We have our MIDI in object, which will pull MIDI information in from Ableton's track and plug out an audio out object for getting the audio back to Ableton. I'm actually not going to use MIDI in. I'm going to use an object called note in, which will bring in note information, and I can very quickly look at that. And I've been doing this stuff quite a long time, quite a few times, using empty message boxes and the right inlet to monitor what's going through the patcher. So when I press a key on my keyboard, I get a couple of bits of information. I get a note number, which is that there, and the velocity, which is that there. And I'm going to use the note number to make a saw oscillator do a thing. That is going to be passed via a multiplier for volume control to the output. The saw object requires a number. It in hertz to control its pitch. This is obviously MIDI coming in here, so that those two things aren't going to line up. So if I sent that, which is 36, into the saw object, it would play at 36 hertz, which is very low. So I'm going to use the commonly found M to F converter to convert MIDI note pitch to hertz. Use those for a sec. And then here I'm going to control this volume control here with an envelope. We've been using Surge this morning, looking at the envelopes on there, and in common with most synthesizers, that synth uses an ADSR envelope generator, and there's an ADSR object built into Max here, and it requires 4 arguments: attack time, decay time, sustain time, and release time. We can change those on the user interface later, but for now I'm going to initialize with 1 millisecond attack time, 500 millisecond decay time. Sustain is a level, so it should be between 0 and 1. So let's make that 0.5, and then release I'll make that 250. I don't know, kind of half making that up. That goes into the multiplier there, and then the ADSR will need to be triggered with a signal or a number. A typical way to do this in Max is to use the note velocity, which currently will be in the range 0 to 127. So it needs scaling down. So I'm going to divide that by 127 in floating point. The dot's really important. It's quite a frustrating feature. We can see that we've got a full stop after the number to indicate that we're working in floating point. If we don't add that, what will happen is any velocity that's not maximum will be turned into a 0, so we won't get any sound. That goes into the ADSR. Now, hopefully, when I press some notes on my keyboard, I get a little sawtooth way of playing. I'm just playing my keyboard on my desk there. So that's cool. So building a really, really, really simple oscillator-based tone generator thing is pretty straightforward, and that's what it looks like. There's a couple of things that we need to do to kind of really fine-tune how it works. So for example, at the moment, if I play a note and then play another note and then release that note, all the sound stops. I can view this using you can see what I'm doing with a key slider here. So I'm playing C, playing G. I haven't let go of C, but if I let go of G, the sound stops, which is different to how a mono synth would operate. And we saw that on Surge using the mono modes, is that normally there'd be the first note would stay there sustaining. There's an object that handles that. It's called DDG mono, and it gets wired in between the note in and the rest of the patcher. Let's cable the key slider in there now. We should see how this works. I'll hold C, then I'll hold G. I'll let go of G, and C plays again. So now it works like a mono synth. In fact, there's an attribute on DGG mono that allows me to change the legato mode, so I can set it to true legato. So it works as you might expect a mono synth to work. I could probably make that a message saying legato mode 1 to default that. And here's a little trick. If I want that to be the default mode when I load the excuse me, when I load the device, I need to say load bang and send a bang to that message so that when the device loads, that object will be initialized to work in that way. I can get rid of that. I'm going to save this. I've started working in a specific place for Max for Live development, so I've got a folder somewhere in my music folder on my computer called Max for Live Devices, and then a development folder. And that is also down here in my browser. So rather than use the default place for Max for Live devices that gets sort of sucked into the system somewhere, I've got a nice, neat and tidy folder full of patches that I'm developing, which might be useful. Okay. Do one more thing here, which is add GUI elements for the ADSR. There's a number of ways of doing this. The simplest thing to do is simply make some live dials for each of these. I'm going to need 4 of them. That's my sustain. These 3 are going to have the same range. They're all going to be 0 to 1 second as float. And this one's going to stay as 0 to 1. So 0 to 1 as float. That will be called attack. Frustrating. Probably a better way of doing this. Decay. Sustain. Yeah, so the key thing here is to make sure that your sustain dial for the ADSR object doesn't go above 1. If it does, it will push the volume of the multiplier way above 1. Then we'll get clipping. So attack, decay, sustain, release. Now kind of got a monosynth. There's one final thing to do with the ADSR, and it's quite hard to explain what this actually means, but I'll try. This is a linear ADSR, so it works in straight lines because it's digital. We might be able to see this on a scope object, but I'm not sure. Let's see if this actually does. Yeah, look. Let me see the straight line there. Make the decay shorter, we'll see it. It's a straight line. It's not really how analog synths work. They're curves on envelopes, normally that way for attack and that way for decay. We can fake this by using this little trick here, which is to multiply the output of the ADSR with itself. This seems like quite a nuts thing to do, but it works. Now it's a curve, look. It's curved, not a straight line. Why is that? Well, we're multiplying its output with itself. Its output is in a range 0 to 1 because that's the range that I've given it with this multiply object here. You multiply 1 with 1, you get 1, right? You multiply 0 with 0, you get nothing. In between those two values, let's say, for example, the envelope's halfway up at 0.5. 0.5 times 0.5 isn't 0.5, it's a different number. Gets calculator. 0.5 times 0.5. It's actually 0.25. So halfway up the envelope, it's actually only a quarter of the way up. And that will create, if you were to extrapolate that slightly rubbish maths explanation from every value between 0 to 1, what that will create is a curved shape as the volume goes up and a curved shape as the volume goes down. So this is not exactly the way an analog envelope would work, but it's closer, will produce a more natural sound. Okay. So that is my finished, very, very, very simple saw wave oscillator. And if I close the device down, there's nothing going on with the user interface at the moment. I'll lose the latency that I was experiencing while I had the editor open. The latency is really only there because Max is receiving MIDI from a different application, then processing it and then sending the audio back out to live. So it's a little bit of a round trip latency there. But once you've finished building your thing, latency goes away. Now, this is rubbish. Well, it's not rubbish. I mean, if I had lots of them, it might sound quite nice. But it's not the Platts oscillator that I want. So how do we get that working? Well, there's lots and lots of places that we can go where we can find Max externals. This fella's website, Volker Bohm, and also the Max Objects. Database, which has lots and lots and lots of objects from all sorts of places for putting into Max. There's a kind of default place where you can put these on the hard drive, but I like to make my own little place for them. And the way we do that is in the Max application, we go to Options and then File Preferences. And I've made myself a folder here called Externals that's on my hard drive in my folder, Music, Max Externals. So then what we would do is we would go to our Max for Live. Let's try this with something. There's a good one called Bonk, which I always like. Bonk external percussion follower. Don't know why it's red. Let's try it. So we click on that. We find the home for it, which is somewhere else. It's quite a long-winded example. There we go. Bonk percussion follower. We download the thingy. And then what we'll get is a folder with the object in it. The bonk object itself, and then the help file for it stuck in a folder. Now, if I go into my Max editor and I make a new object and type the word bonk, it will go, don't be silly, there's no such object as bonk. Why would that be the case? However, if I open up my externals folder here, which is in my music folder, I go to music. Probably should have done it that way around, shouldn't I? We go to music. Externals. I've already got some in here. I've got all the Mutable Instruments objects already in here. We simply put that in there. Then we can type in bonk, and as if by magic, we now have a new object. And if I select it and go to help, we'll also get the help file it's gone that color because it's not allowing us to load the object, and I'm not sure why that is. Might be because it requires an argument. It might be because the object's broken in this version of Max. Either way, we can see here that I've got a load of different externals. This one's sliced, is used for slicing up. Yes, it does work. Is used for slicing up audio files. So if you want to do transient-based slicing in a Max patch, you can do it with Slice. Not something you can do with Max Vanilla, if you like. Anyway, what I'm interested in is the EB Mutable Instruments Plats object. There's quite a lot of inlets and outlets on this object. So we need to work out how it actually operates. We do that by opening the help file, which is wonderfully illustrative. And we can do this with any help file. We can actually steal bits from here to put in our patcher. Like, for example, here is a menu object that's got all the different synthesis modes for Plats. So if I copy that, I can paste it into my patcher, and that needs to go through a message called engine with that thing there. Remember that thing there, the $1, that's a variable. So what that will do is create a message with the word engine and then a number. I can show this by printing it, actually. Let's print this out. So if I change this menu item, it says engine 0, engine 3, engine 8. We send that into the Plats object, then we can change the synthesis engine. But anyway, let's put this in position in here. So I don't need my saw oscillator. And as it happens, the Plats implementation here, Volker Böhm's implementation, it says here that the volt per octave input is volt per octave, which is kind of meaningless in digital synthesis because there is no volts. It's arbitrary. Actually, having tried this before, it seems as if the correct input here is a MIDI note number, which works nicely. So we don't need this either because that's converting to frequency. So we come straight out of DDG mono, straight into Plats. The Plats module here has got two outputs, out and aux. Out's the main output, aux is like depends on what the algorithm is, it's sort of sub output. On the object, that's the main output, and then that's the aux output. And then this, which is kind of common to a lot of modules, is just sort of an information dump, should we need it. So that goes in there. Now, if I turn up sustain, I don't need that scope anymore, do I? I should. Yeah. I'm getting an error. Now, it's a little bit kind of inconsistent how this works, but this input here says it requires a signal. It says signal. These ones say signal and int. Okay, so we need to convert this piece of data coming down this cable here, which is a number, into a signal. And we've used previously to drive the groove object, we've used the object sig, which takes a number input and converts it to a signal. And that should solve the problem. Now I've got a sound. It's a little quiet. Let's turn it up. So going back to originally playing with plats, if anyone was able to join me in the in those sessions, or there's a video I did on plats, I think, or the VCV rack version, you'll recognize some of the sounds that will come out of this. So if I change the engine to chord, we've got that sound that always catches everyone's attention, the chord generator. And now I need to figure out how to change the tonality of it, which again I can just steal all the controls from the help patcher and stick them into my own work. And so that one, and we just line up the dials. So that one's frequency. Actually, maybe you don't need that one. That's harmonics. Actually, frequency will go in there, won't it? So where he's put his? No. Let's get rid of that one. Timbre goes in that one. Morph goes in that one. That one's the trigger input. So if we were using it as a percussion generator, we'd use the trigger input. And that's the volume level. So actually I could use the volume on plats instead of my separate volume control here. But anyway, so let's see if this works. It's quite convincing. There's a few other sort of parameters we can add to this. The main parameters here we've just seen, that's exactly the same as these here: frequency, harmonics, timbre, and morph. The other hidden parameters are what you get when you, I think, hold down one of these buttons and turn a dial. So you can change the way the internal LPG works, what the kind of octave range is. The attenuverters are those things there. So they will control the amount of modulation from the inputs to timbre, frequency modulation, and morph, respectively. And yeah, that's it. So what we kind of need to work on now is what the user interface looks like, which is where we can have a little bit of fun. I think probably the most important part of this is going to be what the selection process looks like for the engine. This is a basic menu, but there's a number of different ways of doing this. So for example, on plats, it's a row of buttons, or a button that selects a kind of radio box. So what we could do is use I can't remember what the object's called. It's called something like radio. Radio group. We could use this. And if I go to the information, I can increase the number of items. So let's say we have 8 items in the radio group. We can select between them like this, which is pretty groovy. In fact, what we've got on plats are 2 buttons, a toggle for the left one, a toggle for the right one. So we could make another one of these radio group things to switch between the 2 banks and make it behave much more like the plats module. But then this seems a little compromised, and I wonder if there's a neater way of doing it. Like, for example, we can go into the menu item here, and we can see what all the things are. Each one's just tied to a number that selects the relevant engine inside the Platts oscillator. So if I copy that out, I can perhaps add that into a live dot menu, which is a little more kind of flexible in terms of what it can look like. Or, so I just go into the range, paste that in where we don't want the commas in here, because the commas will render themselves as separate menu items. It'll go a bit weird if I do that. So I'm just going to go through and delete those things. But it's important to do this because once we've got the text, we can do other things with it. Oh, you know when you're halfway through something and you're like, oh, this is boring, but if I start again, it's going to be even longer. Yeah, the difference in formatting between the two objects. So the usual U-menu object, you separate each item with a comma. With the live dot menu, you separate each item with a space. Yeah. Now I've got a drop down here, which looks a little bit more live-like. I can change the way that behaves. You can make it into a radio button thing somehow. But also we could use live.tab, which gives us a little a different way of looking at this thing. So if I paste these items in here, it's lots of items, so it's gone a bit weird. There we go. I guess the catch here is making it fit in a Max for Live device. I'll probably change the spacing. And I can probably change the font size. Maybe it'll fit. Nope. Really? Yeah. Just about get that in a device window. Maybe I can make that font size smaller. But yeah, that would work in the same way. So then what that will do is enumerate the item, and then I'd plug that into my message window there, and then I can select the relevant engine. So there's a number of different ways of doing that. While I'm at it, there's also a number of different ways of doing the ADSR thing. If you like dials, that's cool. If you don't, what we could look at is something like a multi-slider. If we give the multi-slider 4 sliders, number of sliders, 4, and give them a range that approximates the kind of thing you find on an envelope, then you can make more of a kind of interesting user interface object here, and then you just pull that data apart and stick it into the ADSR. And there's also an object called function that's a kind of breakpoint generator you can use to create envelope shapes somewhere along here as well. It'll even do curve shapes. Can't quite remember how you do that. Yeah, so there's different ways of doing the control for the envelope too. I'm a fan of doing it like this, quite like the minimal display here. But you could use something like J Knobman to make your own envelopey looking things. So there's quite a lot to explore there. I'm just going to jump over to the stream and see if there's any comments popping off. Not really. There's quite a lot to explore there, and So to summarize, okay, so if you want Max to do a certain thing and it doesn't seem apparent how you do that, even with a little bit of knowledge of how the patching language works, it might be that it's not something that Max can actually do, and you'd require an external to do it. So a good example there is the slicing engine that stuff like Ableton has built in. If you want to do that in a device, there's no way of doing that with Max's built-in range of objects. But because Max is quite an old programming language and lots and lots of people use it, you might well find that some clever programmer somewhere has made an external that does that job for you. Same thing with stuff like reverb. If you want to build a reverb, you can do it from objects, but it's very long-winded and doesn't always produce the results that you want. You might find there's an external reverb that works really, really nicely. So to add your externals, you would jump to your file preferences and then add them into the path, and then you just put your externals in that place. There's one final thing to look at here, and as some of you are probably aware, we're hosting a guest Ableton and Max for Live dude in a couple of weeks. Mark Towers, who's a really talented guy, and he knows an awful lot about packaging up devices for release to the world. If you're going to use an external, first of all, you'd have to make sure that whoever made it is okay with you adding it to your own work. And quite often, like if I load in Slice, you'll see we get somewhere. I haven't initialized it properly, so this might not actually work. Anyway, you'll get a little. This was developed by bit of information when you load the device in the text there, so it's quite often obvious to someone picking apart a device that an external object's been used. Some of this stuff is open source, like all the Mutable Instruments code is open source, so which means that someone like Volker Böhm can't say this now belongs to me, because Mutable have already open sourced the code, but he's put some work into this. So I would say if you were going to do this and release the device, then you would also definitely have to credit the programmer for their work and probably drop them an email. But the other question is, where does it go? You can, as well as putting your externals in the general externals folder, what we could also do, if I was to save this, okay, and then just jump to the folder that it lives in, what I could do is make a folder for the object, put my device in there, and then put my externals in that place as well. So which is that one, isn't it? So I'd make a copy of my externals and then drop that into the same folder. As long as the externals are in the same path as the host patcher or the host device, when it's loaded, it will see those externals and load them correctly. So if you were going to, say, build a device that relied on some externals and then submit that as a piece of coursework, you'd put everything in the same folder, including the externals, so that the device will pick it up and it will still operate. And then when you're ready to release your device to the world, you'd package the whole thing up, including the externals, in one big file, and that would be what your end user would install at the other end. So there are a few kind of grey areas with using externals, but I think the fact that you can almost infinitely extend what you can do in Max, and therefore Max for Live, with things from all around the internet, I think it's kind of amazing. And my final piece of advice would be, which is a piece of advice I was given very many years ago by another really good Max programmer, whose name is, and I'm not joking, his name is I Am the Mighty Jungulator. Look him up. He said, you learn one object really, really well. So learn what it can do really, really well. So maybe what I would do here is learn Platts as an object thoroughly, and use that to create something. It's good advice. Or if you can use buffer and groove, for example, or slice, spend some time learning the object really, really well. Okay. Okay, well, happy patching, and I'm about for the duration of the day. If you watch this and you went or you watched this and went, what was that other thing? Feel free to drop me a line. And in the absence of any other questions or comments, I will say goodbye. So, goodbye.